phosphate. Step 1, magnesium phosphate. If you don't know that, we're in trouble. But also, you probably should reference your polyatomics until you're good. So, Kareem, magnesium phosphate. Ready when you are. Give me at least the first part. Thanks, Kareem. All right, Josh, you want to pick up the phosphate? So that's PO4. I'm going to go ahead and write the charge of phosphate, which is what? 3 minus magnesium. Look at the periodic table. 2 plus, this is in group 2. Crisscross those, and what do you get? Mg 3, PO4 2. Okay, so that's magnesium phosphate. If I ask for the percent composition of magnesium phosphate, that means for every single element there, we need the percent comp, or the percent that it makes up. How many elements do we have here? Elements? Whoa, whoa, whoa. How many different types of elements do I have? Magnesium, phosphorus, and oxygen. So I've got 3 elements. I'm going to find the percent magnesium, percent phosphorus, and percent oxygen. That's my question. Okay, let's go ahead and start with the percent magnesium. Your setup is very simple. Percent magnesium of magnesium phosphate is the number of magnesiums. How many magnesiums do I have? 3. There's a subscript that describes it. That's 3. So that's 3 magnesiums over, and I'm not gonna put the mass just yet, but I know that we're gonna be using mass, so I have your periodic tables out. So how do I add up the total? What would you normally call me adding up all these masses? Molar mass, right? We're just gonna find the molar mass of magnesium phosphate. So that's 3 magnesiums plus how many phosphori? 2, right? That 2 distributes into the 1, so that's 2 phosphori, or phosphoruses. And how many oxygens? 2 times 4 is 8, correct. Okay, so we've got 8 oxygens. Okay, so periodic table's out, and I really do believe in seeing the periodic table over and over and over again, because that's when you start to lose time on assignments or on quizzes or on tests, because you have to see the periodic table enough to know where everything is, right? So you should be able to really quickly find magnesium, phosphorus, and oxygen. And Haley's group, can you guys tell me magnesium's mass? So 24.31 is, I think, what some people say, or rounded. Okay, so that's 3 times magnesium's mass. That's our numerator. Then we're going to divide that by, and I'm going to write all these out for now. You in the future do not have to write everything out if you want to calculate in your calculator, but I'm modeling for you what you should be doing. 3 times magnesium, which we've already established is 24.31 grams. Anel's group, what's the mass of phosphorus? 30.97, so that's 2 times 30.97 grams. That's just the phosphorus so far in magnesium. And then Tessa's group, oxygen, 15.99. And some here, like I said, some say 16.00. Use what your periodic table says, and I always will reflect on yours. So this is all we're doing, part over whole, right? So the part that we're interested in is magnesium. The whole shebang is the whole shebang. And then we're going to divide this and multiply by 100, and we're going to get percent magnesium. So I'll let you do it in your calculator now. If you don't have a calculator, then raise your hand. We're going to just pass the whole bucket around. So you can just add up the denominator. Anybody? Oh, you don't? Oh, right behind you. Go for it, Shannon. So this is 27.7%, right? Does percent have a unit? Does percent have a unit? Get your name. No, it does not. All right. This is grams on top. This is grams on bottom. The grams and the grams cancel, leaving us unitless. And so give me a raise of hands if you got that right. 27.7. Or give me a raise of hands if you're like, I think that isn't wrong on my calculator. So probably what happened is you didn't put enough parentheses in your denominator, or why don't, just to avoid that, why don't you just calculate the entire denominator's mass, and then separate step divide. And also, what your calculator does, it just doesn't understand what you're doing. It needs to know that this is 3 times this before you divide. So you just need to speak very clearly to your calculator. Very clearly. Okay, so that's percent magnesium. You guys tell me how this changes when I do percent phosphorus. What's the only thing that will change? Say again? Yeah, the phosphorus will be the only thing that we're looking at. So the percent phosphorus will be 2 times what? 30.97 over, what's the total mass? Did anybody calculate that? 260 what? 0.87, something close to that. Okay, so this is grams of phosphorus divided by grams total times 100, and what do we get for phosphorus's percent? Say it one more time. Thank you. Okay, so far so good, right? We get percent so far. Part over whole, you just have to make sure that if there's a number of them, you have to put their total mass on the top, meaning like 3 magnesiums or 2 phosphoride. Now, I'm actually not going to do the same process for oxygen's percent. What's another way we could get oxygen's percent without doing this exact same process? Jake? From 100, right? So for percents, all the percents add up to 100. That makes it a little easier. So what you can do is go, okay, magnesium, phosphorus, and oxygen together equal 100%. I already have magnesium, so I'm going to subtract 27.7. I already have phosphoruses, that's 23.56. What's my percent oxygen? 48.74, something like that. Okay, so this is just an alternative at the end when you get to that final element. Give me a thumbs up if you feel you could do that for any compound as long as you knew the formula. Okay, similar process to any percent maybe you've done in the past. I'm going to pause for a second. Let you guys kind of catch up with me. We're going to do this one together and then I'll be good. Yeah. Yep, because the 100 is our total mass. Percent magnesium was 27.7%. Phosphorus was this one. So this is going to give me that remaining part. Sometimes it just helps speed up your work because you don't have to do all the crazy math. Okay, so I want you guys to think about this last question I'm going to do right now. I want to see what you think you should do before I tell you what you should do. So if you have a 54-gram sample of magnesium phosphate, how many grams of that are oxygen? Don't shout it out. Just raise your hand when you're ready. It's like if you go to the store and you're trying to figure out, it's 20% off. How much is that? So you use the decimals and percents all the time. Joey, what you got?
26.31.
Okay, tell me your process.
So you know that oxygen correlates to 48.74%.
Okay.
So all I did was move the decimal over 2 places, so you get 0.4874. Grams of oxygen.
From your total sample.
Yeah.
Okay, so does this have a unit? Yay or nay? Did it have a unit here? Does it have a unit here? No, it's just a different version of percent. We've bounced the decimal back 2 times. We're going to take our 54-gram sample total. And so you multiply your 54 by the percent as a decimal, you get, what do you say,
46.3196.
21.3. We need 2 decimals there. 2. Okay, so what you should see isn't 48% about 50%? You know, give or take. So half of this sample should be oxygen, right? Isn't that about half of 54? Yeah, close to it. So what you should see is that you can logically make sure that it makes sense at the end, just to make sure you didn't make a mistake in your math. So this is basically what we'll be doing with percent composition. It's not hard at all. It's just understanding the idea of part over whole. Okay, do me a favor. Go to my website. And you're going to see, when you get to my website, you're going to see something that says like percent hydrate, simulation. But that means you have to know what a hydrate is. So hydrate, we actually already did one example in our problem set 9, which I will give you back tomorrow so you can study. We did like cobalt 2 phosphate decahydrate or something. I want to make up a different one, and I want you guys, while it's pulling up, this is under Unit 4, by the way. Unit 4. What you'll notice in this, I told you guys this yesterday, I'm blending Unit 3 and 4 because I know you're not ready for nomenclature yet. You just need to keep following. So what is the formula for copper 2 sulfate pentahydrate? I'll say that again. Copper 2 sulfate pentahydrate. Talk in your group for a minute.
Yeah, it's this is 3 like sulfide.
What's hard?
Yeah,
What does it sound like? If you are hydrated, that's that one weird example that has a number of like that dot water.
OH.
All right, back to me. I hope that you've had enough time to chat. So can you guys tell me your process here? Kyle, what's copper's charge? Oh, well, you had about a minute to that, so I'll help you out here. Copper has a 2 plus charge, because that's what the Roman numeral is always describing. Izzy, what's sulfate? It's not on the periodic table. It's not one of the ides. Remember, ide means you look at the periodic table. I'd rather use a periodic table. Ides go to the periodic table. 8s are from your brain. Polyatomic ions. Anybody? SO4 what? 2 minus, right. So, crisscross those, what do you get? They cancel out, right? CuSO4. And that 2 and 2 that were there, reduced down to 1 and 1 to simplify. And then the separate step is like the one where we have the dot, and then we have to say a number. And what's the number? 5. And what does hydrate refer to? It refers to a sample is hydrated. So if you're hydrated, you drink a lot of water. So just like a sample can be hydrated, it can have water surrounding it in its crystalline structure. And so a hydrate means there's, in this case, 5 waters. How would I find the molar mass of this? Please do not say multiply. This is not a multiplication symbol. This is literally a dot. Just add, right? Copper plus sulfur plus 4 oxygens plus. You can add 5 waters, which would be 10 hydrogens and 5 oxygens. So just make it work for you, but that's how you will be calculating that in the lab when you get there. So the very first thing you guys are doing in table groups before you start that simulation, the simulation itself is very easy. This part right here is going to be referring to what we just did in class. So this should take you about 10 minutes. This is your pre-lab, and this, I don't think that you'll be able to put all this on the same sheet unless you're crafty, but if you would like to write some separate sheets or separate simulation. If you can't find it under documents, let me know. So what I said, when I want you to do in the group, I want you to talk in your group and make sure you're helping each other through. Everyone is writing down information because you guys need to make sure you're forcing your hand so that you remember how to take me up to the phone. Your brain and hand makes a lot of connection. Can you get started on this first? So you will finish this. We have 35 minutes left, and we'll finish this by the end of class, including the simulation, I hope.
The massive element, so that at least be like 1. Oh wait.
The first
Oh,
one
1.
is 2 silver and 1.
Yeah, sorry, I thought. So 2 AG over just all of them, right?
2 AG, 1 sulfite, so it's over, that's 66.4.
Percentage? Or the molar mass?
Yeah, percentage, so
Oh, it's AG2.
Wait, don't we have to do the thing with water?
Yeah. Percent composition?
Yeah.
oh,
So it would be,
oh yeah, yeah. I was just thinking like,
so it would be 2 times 107.87.
Wait, I thought it was aha, yeah, you're right. I was looking at so 2 times the mass of silicon.
And the bottom.
Yep. And the top.
Mine
Because
has
we're
like,
doing it's 107.87 times 2 on the top.
over 2 times
Plus
sulfur is 32.06.
yep.
I'm just thinking 6.
That's on top there, right?
Yeah, that's on top, and on the bottom there, have that.
Alright, 247.8.
Don't you divide?
Yes. So it's silver divided by silver.
And then multiply by 100.
Yeah. Although, that's 247%.
I got 87.
Yeah, I got 87.
Or 87.06.
Okay,
Yeah, 87.07.
06, but yeah.
Oh yeah, 06, yeah.
I think it's just because they all have like different things. I want to figure out a
I like
years.
times mine wrong, so I have to.
So calculate the mass in grams.
That's number 1.
It takes 6 seconds for that.
Wait, really?
The lowest is 4.
So we can go with 4.
Oh, I forgot to that.
So you would choose 4.
So it's just 87.06.
Yeah.
And then, okay, so for this one, do you just, you take the final answer and you move it 2 places over and multiply by 10? No. It's like 0.8706 times 10. And then you get 8.706 for it.
Wait, what did you get? 8.7.
I got 8.706.
So times 0.8706, right?
Or don't you do it? Yeah, 0.87.
Uh-huh.
The big has to be 8.7. It's 10.
Oh, yeah.
Well, it's
Do you know
10
it's
is yes, 3.
So
So
7.1.
7.1.
Yeah.
1.
So,
Don't have grams. Follow H3.
and then define the terms hydrate and
You skipped 3.
yeah, well 3A. 3 is not really like a problem.
Called barium hydroxide.
Hydrated.
Water.
Find the terms hydrate and hydrate.
What? What is that?
Anhydrous without water.
Oh yeah, that makes sense. Okay, and then B, what is the percent? I don't even know where to start now. Like, I felt so confident.
Why?
So,
Number 2 is just like you did in class.
Oh, no, number 3B.
People can't act serious in the hallway.
where you
Because it's 10 grams. And then you get like 8.7.
Oh.
but, okay. I'm doing like,
I will not do
I'm
it.
just gonna write
One time it happened,
or water. So you're trying to do, so you're trying to figure out the percentile mass of H2O and all of that.
Yeah.
So you would do the same thing as water. So it'd be, that would be 16 hydrogens and 8 oxygens.
What? 0.008, and then plus
8 this is 0.9.
for what? Sorry. I said hydrogen is 1.00 times
Oxygen is 15.9.
9 times 8. And what goes on the bottom? Everything else?
Yes.
Oh my god.
So there's barium, which
Wait, what's the
is
total?
137.3.
Total of it? I figured it out. Let me do it.
Oh wait, hydro.
just do it by like each element. So there's 2
Oh,
oxygen
oxygen.
on the left, and then there's 8, so that's 10 oxygen.
3.99 times 10. So is there 18 hydrogen?
Yes.
Yes.
Oh, yeah. Put that on.
So 137.327 plus 10 times 15.99 times 18 times 1.
Okay, I actually get something.
This is surprisingly.
Okay, so
Now it's just the simple fact of talking about
I'm not doing it. So I have not calculated that.
What is it?
Okay, so 137.33 plus 10 times 15.99. 10 times. And then plus 18 times
0.4567572.
Yes,
315.374.
Now, what's on the top?
I have
45.68.
I got
I got 69. I got 0.4567.
Guys, help your groups out. Help your groups out.
Did you use 0.99 or 0.99? 0.99.
What is the bottom number?
45.66.
Yeah. What is your answer?
45.7.
Okay, that's right. 45.7.
I got 45.
7 here.
So water is 45.7%.
Oh, that's easy to do. Huh?
10 times.
3B. We got 45.7%. Because, okay, so you know how there's 2 hydrogens in OH2 and then 16, so it's 18 altogether.
Okay. No, it's 16.
We got to break it down by like
It's 16 hydrogen and 8 but that's only one. There's also one oxygen.
You guys got 4.5.
So that's 1/3 of the question. Now on to number C.
Oh, it's 4.5 grams of water.
4.57.
Oh my god, this is so. I'm gonna. Actually, watch the fields on this one. It's just more, and I'm gonna be like, okay. Watch.
Yeah.
That
It's gonna be like 2 points.
that is like 4 and 1. So no matter how complicated it is,
I'm starting to know the, I don't know.
Yeah, that's it. I was ready to nope.
make one of those.
Oh, okay, no, you're good. Yep. So what is, I don't know how you got this one.
Oh, isn't it like,
Oh, did you want to which one you were? Give me a thumbs up if you made it through C already. Alright, I know some people are still working there. I want to give you a tidbit of information that will help you progress to the next section. When you get to the simulation, listen for 1 second. When you get to the simulation, the only reason you need simulation is for those first 2 pieces of data that they give you. They give you this blue hydrated version that's like 2 grams, 3 grams, 4 grams, but literally every person who does a simulation gets randomized information, randomized data. So JT and Lyric could do it at the same time. They're going to get randomized information. So if you want to be able to work with someone with that data, sit next to them. Okay, we're going to use this data. We get the data. We let it dehydrate. We make the anhydrous sample. We're going to take that data, because if you guys use 2 different computers, you're going to get 2 pieces of information that's different. That's just hard to have a dialogue about, because it's different stuff. So make a decision on how you look at that data. That's all I'm saying.
everyone would do one, like all of them. There's no way, because you couldn't read it all.
Yeah, if you like.
Where is it?
Go to our website.
Alright, so we started with another math, but I hadn't seen
No.
So I divided 2.144 by that.
I'm sure you
It says read the information before there.
I'm just like looking at the
Can I turn it just a little bit so I can see?
We have to find like the water molecules, right?
So, read information on the right of it, sulfate is a glucose, and then you get one water molecule from the PA because the two find many uses in agriculture as inside of the
So with that, you put one more water.
When you glucose in solid, you heat it in air, it loses its water crystallization, forms anhydrous white copper crystal. From the number of water molecules, the third one is copper 2. So H2 hydrogen is only plus one process from the direction of the
That's
we
not.
have to do what we can do.
And basically, the mass of H2O is 18.016
True, because there's not like 2 separate.
oxygen. And so multiply the mass of water times 9 to the approximately.
So what are we trying to find? Water?
Determine the number of water molecules per unit of copper.
Yeah, that was easy.
That was so.
So do you just put copper?
Yes. And I got
No, it's gonna be 3.48. Copper, sulfate, iron. So that is Cu, SO4, 2 minus, and then your hydrate is
So, are we calculating some tape?
The charge?
it's Cu.
So that's already close. I don't need charge. Okay, for both of them, for the copper sulfate, both of them need
I'm writing down what this is.
Oh, right there.
Yeah, yeah. I mean, well, I kind of like created another one. We're still in we're all using the same method. Because literally in the whole formula is still running. We're right there.
Yeah, I'm not even.
Yeah. So overall, you're there was also this is terrible. This is way
That's why I'm not making it rough. Like,
I'm just writing the labels as well.
exactly. That's what
Yeah, I got 2.06. 2.06.
Yeah. Oh no, we're still writing.
Total mass of total water. Now you can calculate.
Oh, they are.
So what I did is I added, I went to the airport and I could do it. So I'm doing barium, 137.
It's too thick, but yeah, you're right.
And then the next part, I got two oxygen and two hydrogen. How much is here? 16. There's two oxygen. Two hydrogen. That's
Okay, so we need to pick it up. We have anything to begin with? Initial mass of.
yes, 0.115.
So what is it? Oh.
I just calculated the
So 0.
Alright, you guys kind of went.
No, we haven't started on it.
Yeah,
We only got.
do you remember earlier when we got the 18 mass of 1 hydrogen? So it's going to plug that right in. Yeah.
Honestly, it's so easy.
I just don't like that. Yeah, I'm taking it. You guys all have rules.
The only problem is like AB schedule. So it's like,
I like it.
I kind of like it.
yeah, but like occasionally you'll get like 2 days of reading.
True. But I always do have this I don't do like if I have to read homework, then I do it 3 days later.
Yeah, same.
That's for if it's like something I'll take one day. But if it's like a 2-day thing.
Then even then I do it like probably why.
I think
I'm an extremely last minute person. I haven't even started my beta application. I would really appreciate I got it from Robeson this morning. I literally almost I've had her for 2 years, so yeah, for Excel and Access. So I feel like she would give me like a in the middle at least.
you're in first period. She'll give you she'd like give you 5.
I'd be like, oh my god, thank you.
Yeah, so I know everything is going on.
I literally.
Are we allowed to do that?
Yeah, but the
voice thing is
I'm trying to look through it in the light, and I'm like, what is it saying?
I get installing.
Guys, I hear you also have a conversation, and I will raise you in detention. Let's go. You have 15 minutes to get this done.
They're talking to
It's still heating.
We'll just write that down before it goes away. 0.0741. Reset time.
Also, that's the mass. Copper. That's the
Okay, so it's the 0.0. Okay, what's the mass ratio? Subtract 1159. So 0.0741.
Okay. That's the final mass. That's the same thing as the mass of copper. You said it was 8 oxygen.
Oh, because it doesn't have
Yeah, I believe we water. Yes.
Okay, so
No, I'm sorry. I think it's, oh, I know. Yeah, sorry. I think that's the last
this is oxygen, that's hydrogen. 16 hydrogen.
out of the area.
Because you know how there's 8 times. Yeah, and then
like the mass of whatever it is, would that be the same as the final mass?
The mass
The
of
copper
since the oxygen is
the hydrogen from both of them.
I'm gonna pull up this chart. Give me a
You
second.
see, like right here, there's a star. There's a star in these. That star says 2.
yeah, it also says it has an S next to
What's
the
that
one
mass
between the solid and the other one.
I believe it's 0.04.
Maybe just approximately. So what?
I'm gonna answer that for you in just 1 second. I'm pulling up the simulation.
Water. You have the original, and then if you take away the mass of copper sulfate, then you get 0.0418, which I believe to be the mass.
Yeah, I think that's right.
I mean, I propose. I don't know if that's
No. JT, you guys okay? Let me explain it for the whole class. So I just want to make sure everybody's on par. They're about your data. All right, guys, look up here for me real fast. I want to be able to explain this for the class so that no one is confused when you leave me. So I need your attention in 5 seconds, please. Thank you. Okay. So you guys have seen this chart. So I'm pretty sure there are some answers in here that you just neglected reading. To be honest, you just haven't read, and that's something you need to do. But you also see the CuSO4 question mark water. And so that confused some of you guys because I'm not sure you've looked at both places. So when you're here and you see your hydrate, it's blue. Then you went forward and you saw there's a mass given, and everyone's mass is different. But then it says CuSO4 X water. It's not telling you the waters because they want you to figure out how much water is there based off the data you collect. So as you're seeing that, don't be scared. Question mark and X kind of is interchangeable for us right now. And you're going to heat your sample, and as you heat your sample, it's going to end up with the final mass in a second after it kind of gets all the water out. So that mass difference is what? What's happening to our sample? Okay, the water's what? Evaporating, right? So that mass difference is water evaporated. So on your chart, when you see, so I'm going to come right back here in a second, what you'll see down here is that the initial mass is that very first mass on the very left-hand side of the simulation. The final mass of just straight up copper 2 sulfate, which is what this is, question mark water, that's that final mass after the water has been evaporated. That final mass, that star actually does mean, write that same thing again. And that's the only data you need from that simulation. That's it. After that, it's all you. You got to calculate. So once you get your mass here, which is from the simulation, nope, not gonna work. Okay, I was gonna try to write on that, but that's just straight from the simulation. You're then going to take your mass of copper 2 sulfate, and you're gonna compare that to the original mass you had, just like you did in your pre-lab with your silver sulfate or sulfite. You're gonna put your copper 2 sulfate mass over the copper 2 sulfate question mark water. But this data you have from data, not from calculation of Cu plus sulfur plus 4 oxygens. It's from your data. You with me so far? That's how you get your percent copper 2 sulfate in this hydrate itself. Okay, how would I get D? You subtract, that's your mass difference that the water evaporated out. Then how would I get percent water in hydrate using my data? Divide D by, what's the whole thing? The first one, right? That first one is your whole thing. Your first one is your total, because that's what you're starting with. That's before anything touched us, before you dehydrated it. So you always will be really referring back to that initial mass, because that's your total. That's your denominator. You picking up a little bit what I'm putting down? Yeah.
So that final mass is the same as the mass of...
Just straight copper 2 sulfate, because all the water's been pulled out of it.
So the final mass.
Yep, B and C are the same. Alright, I'm going to stop there. You do what you got to do. Let me put the 3 lab back up.
We just did water.
Just so we know.
Copper sulfate. What's D?
C, which is the 0.0741 divided by.
So the answer for E is 0.0413 divided by 1.195.
What is that?
It's mass of water and then over so it's 36. The percent of carbon sulfate. Oh yeah, sorry, that's that.
So F is 36.1.
Yeah, E is 63.9.
Oh, it's really
68.
63.
3.
Wait.
Yeah, it would, because 100% like.
0.9.
Yeah, I
But
think
then it would be point something.
Did you actually think of water already? Okay, what is water?
Yeah.
36.07.
So we just need molar mass and moles.
What did you get here?
63.9.
And molar mass is just the thing with periodic table, right?
Copper is 63.546. And how many is there of that?
there's just one.
Okay.
Plus one sulfur, there's sulfur, 32.
And then oxygen times 4. So it's 16 times 4, I guess.
It's 15.5.
It's either way.
But
This one's and you get
Sorry.
159.5.
Use your data. If you're not using your data, you're probably doing it wrong.
molar mass.
Yep.